Welcome to the place where we gain knowledge through the lens of creativity. I am Aaron Dworkin, and this is Artful Science. Thanks again for joining me here on Artful Science. Today's show is Little Racer, Mercury and the Communication of Science. And my guest is Shoshana Weider, who serves as Program Officer in the Planetary Science Division, PSD, at NASA headquarters. Shoshana, welcome to the show.
Hi, thanks for having me.
Well, I am so excited to be able to talk with you both about kind of how we communicate about science, a huge thing that we're focused on here at the show, but also Mercury, which I think as I just kind of think back for myself and I think about the planets, I feel like Mercury is one of the ones that I feel like I know the least about. So I'm really, really interested and excited. So a big part of your work at NASA is related to the Mercury Exploration Assessment Group. So can you kind of share what that is?
Yes, absolutely. So as you say, part of my role at the Washington, D.C. NASA headquarters is working with this new group, this Mercury Exploration Assessment Group, or as we like to call it for short, MEXAG. And so they're actually a brand new formal group, just over a year old. And they are one of these assessment groups. We have multiple of them within the planetary science community, research community within the US. Mainly they are focused on specific bodies or singular body in the solar system. So we have one that focuses on the moon, we have one that focuses on Mars, we have one that focuses on the outer planets, etc. And until last year, when MEXAG became MEXAG, Mercury didn't really have a home within a group like this. So this is basically, the best way I can describe it is a fan club. It's a Mercury fan club.
Right. It sounds like Mercury was left out for many years.
Absolutely, for some historical reasons, but we've put that wrong to right. And yeah, so like I said, it's basically a Mercury fan club for scientists and engineers and people that are really interested in furthering the science and exploration of Mercury as a planet, helping to inform the advisory committees that report to NASA and help steer NASA's science direction within planetary science. Gotcha.
So, and maybe part of this answer will help to explain why Mercury maybe was kind of a little bit on the outskirts, even though I believe it's the innermost planet for so many years. So can you just tell us more about Mercury, right? And especially, a lot of our audience, lay people and people like me in the arts. And so assuming we kind of know almost nothing, if you could just share about Mercury and especially its kind of role in our solar system overall.
Absolutely right. So everyone knows Mercury is the closest planet to the sun, right? It's also the smallest planet in our solar system. So it really is somewhat of an extreme planet. And it also serves as what we call an end member, trying to understand the planets as a whole. Mercury sits, like you said, at the edge, being closest to the sun. So some of the cool things about Mercury, or even though it's the smallest of the planets, actually the most dense of the planets. It also has the highest, what we call diurnal temperature range. So the change between nighttime on Mercury and daytime on Mercury is a huge temperature swing. It goes down to about minus 280 degrees Fahrenheit at night, and then all the way up to about 800 degrees Fahrenheit when it's in sunlight. So it's really, like I said, an extreme planet. So it really does help us to understand the full breadth of the bodies in our solar system, and also now understanding extrasolar planets that we're discovering around other stars in our galaxy.
Gotcha. Just a quick question on that. I'm wondering about that temperature change, which is so dramatic. And is that a function of its proximity to the sun? So in other words, are the planets that are closer to the sun than us have more, dramatic temperature changes, and the planets farther than us have less? Is that the kind of model, or?
Absolutely. So that's part of the story. Also, Mercury has no atmosphere. So it's not like on Earth where you have some of this greenhouse effect where water heat can be absorbed and kept, within the body for longer. That doesn't happen on Mercury. The other thing that affects how the surface is heated on Mercury is the fact that it's trapped in what we call a 3-to-2 spin orbit resonance, which is fancy words for basically every time that Mercury spins on its axis 3 times, it has gone around the sun twice, which is it's what we call tidally locked. So there are parts of Mercury's surface that basically see the sun for longer than other parts. So that's all part of that story of why we see these huge temperature changes on Mercury. The other thing as well is that Mercury doesn't really have much of a tilt on its axis. Like we have what I think it's like a 23-degree axis tilt on Earth, which is why we have seasons. Mercury doesn't have that. So it actually means that at the poles of Mercury, there are craters there. Within those craters, they never see direct sunlight. So those places are always frigid. And we actually think they actually contain some water ice probably in those areas on Mercury, which is always surprises people.
Right, absolutely. So thinking about whether there's water and or ice there, our missions to Mercury, what would you say has kind of been our most important mission, and why?
So going back to why Mercury has kind of been a little bit unloved historically within the planetary science community is really that Mercury is very hard to explore, both from Earth by looking at it with telescopes, because it's so close to the sun, you only ever see Mercury in the night sky very close to sunrise or sunset. So it's very hard to point telescopes at Mercury and get good observations of it from Earth. Likewise, it's hard to explore with spacecraft because you're traveling towards the sun and you're speeding up as you go because you're being pulled by the sun's gravity. So we've only actually previously sent 2 missions to Mercury. The first was in the 1970s. That was called Mariner 10. It was one of the early fleet of planetary science missions. It didn't go into orbit. It didn't land. It just kind of flew by Mercury a few times, took some pictures. We didn't get to see the whole surface up close. It really kind of just teased us with some information about Mercury. And then in the 2000s, NASA sent the first mission to orbit Mercury, and that was called Messenger. That launched in 2004 and orbited the planet between 2011 and 2015. And actually, that's where my love of Mercury really began, because I got to work on that mission as a postdoc, as a scientist for a while.
Gotcha.
And so right now, sorry, just to finish that answer. So right now, the European Space Agency and the Japanese Space Agency have a joint mission called Bepi Colombo, which is actually on its way to Mercury right now. It's been launched. It's on its way. It's due to go into orbit late 2025 around Mercury.
Gotcha. So it's basically with when we launch something, it's a 5-year journey, basically.
Yeah, it's a long journey, not so much because Mercury is that far away, because relatively speaking, Mercury is actually very close to Earth. It's again because of this gravity well that you're being pulled into of the sun. Because Mercury is so small but so close to the sun, it's got a very tiny little gravity well that you need to be captured by if you want to go into orbit. So basically, you want to slow your spacecraft down as much as you can before you try and go into orbit. And so clever rocket scientists have worked out a very windy routes. Basically, you leave Earth and you go slowly, you do circles basically through the inner solar system, flying by the Earth, flying by Venus, and then Mercury a few times before you actually try and go into orbit, just to keep slowing it down so that you can be captured by Mercury's gravity when you want to go into orbit.
Wow. It's really just amazing science. And it's always interesting learning new things about our other planets here in the solar system, which kind of gets me to this whole other part for this show about communication. And so a fair amount of what you do and are so phenomenal at, which is communicating about science. And just wondering if you could kind of share a little bit about that, about moon landings, your book, and just this idea of communicating about science.
Yeah, absolutely. And this kind of is actually relevant to Mercury in itself, right? Mercury was the messenger god, talking about taking messages, right? So it all links in nicely. So yeah, my career has been somewhat windy to get to where I am right now. I'm a scientist by training, but I've also spent many years working in science communication, working in science writing and editing. So one of the things that I was able to do a few years back was author a children's book called Moon Landings. I actually have a copy right here. published by DK, which is exactly what it says on the tin. It talks about the moon landings. It's aimed at the age group of around 5 to 9, something like that, when kids are starting to learn to read on their own. It's a nonfiction book to try and get them excited about space and about the history of our exploration of our solar system. And so, yeah, I think science communication is fundamental, right, to our society. And I think the last couple of years have really demonstrated that communicating science and complicated concepts, whether it's exploration of the solar system or whether it's how we've dealt with a pandemic, is so important, and important to do responsibly. And it's very nuanced as well, right? Every time you talk to someone, you have a different audience. And it's about tailoring your communication to that audience, whether it's writing for 5-year-olds or talking to college graduates, right? It's going to be different every time you do it. And I think that's a really important part of science communication that we need to remember.
Right. Is there a component, because it is, of course, so important as you think about, I spend, so much of my life in the arts world, and just imagining talking to someone or even a young person who's in the arts who says, oh, okay, Mercury or any of our other planets, why should I care, right? I've got these issues here, so on and so forth. What do you say, or how do you communicate about this role of science for either a young person or someone who's in another field who doesn't necessarily see that importance initially?
I would say I actually see science and arts as a spectrum. Science, for me, is about experiencing the world around us, or the solar system around us, and wanting to know more about it so that we can then tell someone else about it, right? Science isn't done until you communicate it. There's no point you just keeping your results in your lab by yourself. That's not science. So having people that are great communicators, whether that's, visual arts, music, writing, any of these things, is so important in being able to tell the story of science. And even I can think of many examples within our work at NASA in the Planetary Science Division where we try and bring in art or arts as much as we can into what we do. And actually, just bringing it back to Mercury for a second, I wanted to mention, because it's highly relevant, is that all the craters on Mercury are named for artists. They're named for, ones I can just name off the top of my head. There's a Rachmaninoff, there's a Beethoven, there's a Mozart, there's a Tolstoy, there's a Shalom Aleichem. So people, when they were thinking about how do we name things on Mercury, they were like, we want to bring in the artists. Another example, we've got a mission that's coming up for launch next year called Psyche. It's going to go to visit a metal asteroid called Psyche. And part of their mission is working with college students who are artists in telling the story of Psyche through art, whether that's paintings, whether that's sculpture, whether that's music. Science and arts are completely embedded within one another, I think.
Wow. Well, and that is totally amazing. I certainly did not know that about the craters. It really is amazing and extraordinary work that you do. Shoshana Weider, thank you for helping us gain knowledge through the lens of creativity here on Artful Science.
Thank you for having me.